Hi everyone. Today we will discuss about the last topic of our series of videos for the substation introduction and SLD introduction. We will conclude and we will discuss these last three items: a medium voltage switchgear and auxiliary transformer and capacitor bank. If you are interested to see the actual videos how these activities are performed at site, please subscribe and share the channel information so that we can be connected together. Let us start with the medium voltage switchgear. This single line diagram, as earlier shown, is showing the three sections of medium voltage switchgear. Medium voltage metal clad switchgear is used for the distribution networks for 11 kV, 13.8 kV, 33 kV switchgears. It has a compact design. It's the indoor type switchgears stored and installed in the dust-free environment, and it is easy to install like a Lego toys. The cubicles, the feeders can be just placed adjacent to each other, and then bus bars can be connected very easily, and it is an expandable design. It has less maintenance versus the pure outdoor AIS switchgear. The insulation medium here is for bus bars is air, and for circuit breakers sometimes SF6 and sometimes circuit breakers. In some switchgears the incomer and capacitor feeders are SF6 type, while the normal outgoing feeders are vacuum type circuit breakers. So let us focus on the one section out of these three. This is extracted one section of the single line diagram. Each section is fed by one transformer feeder at MV voltage level. This is here. We discussed in detail the components in our previous videos. So this is the breaker and others are the CTs, and this is the VT for the incomer. You can notice here the VT is only for the incomer, not for the outgoing feeders. So the purpose of the VT on the incomer is because of the synchronizing functionality which will be required. So at right side, this is a picture of the normal switchgear which we will be discussing in the detail. Let us see, look at the one feeder of a bay. These are the components of MV switchgear for one feeder. Each bay or feeder has LV compartment, circuit breaker compartment, and power compartment having CT and cable, and some CTs are installed in the bus bar compartments. Now let us focus on the LV compartment. At the left side, LV compartment has all the control and protection schemes with protection relays for overcurrent, earth fault, and sometime bus bar protection. In modern MV switchgear, the relays are used as a BCPU. They are bay control and protection units which have the dual functionality. Bay control will give a choice to connect with the substation automation system. Basically, this is the bay control and protection BCPU. So this can be from ABB, from Siemens, and these are IEC 61850 compliant devices which can control both functionalities for the control and protection. Bay control will give you a choice to connect with the substation automation system, which is a modern technology to automize the substation. Before that it was RTU based. Now all the modern substations coming with the substation automation system. So for the relays to communicate with the substation automation system, they should be IEC 61850 SAS standard compliant. So these units will provide facility to apply the desired protection to the system as well as the control. The picture at left is the front view of a LV compartment, and picture at the middle is open door of the same compartment, showing the back side of the main components. Like here, this how these wires are connected with the relays, with the selector switches, with the LEDs. Here you can see this is the digital function meter, this is the main relay, and some other auxiliary relays and lockout relays. You can see here how these components are connected through control cables and through fiber optic cables. These fiber optic cables, the orange color cables, are actually the communication cables to connect the relay with the control system, with the SAS, substation automation system. And this is the terminal block where the wires are connected through lugs and ferrules. These white cable color labels are called ferrules, which are printed at manufacturer facility for internal wiring. While for external wiring, we do the ferruling at the site. The color coding followed here for ferrules are white for the internal wiring and yellow for the external wiring. However, it depends on the standard and approved design. Now let us move to the circuit breaker compartment. Circuit breaker compartment, the middle one, this is actually containing the power circuit breaker, which can interrupt, which can close or open the circuit breaker. So here you can see the circuit breaker compartment contains withdrawable breaker. Breaker can be on and off. These two switches are given there. You can see, I will zoom it. This is for the off and this is to on. Off means open, on means close. So picture showing the local control just over the breaker. This is only used in case of testing and emergency. Otherwise, breakers are controlled through remote control. The next is coming bus bar and CT compartment. From the back side and top of the ME switchgear, there is a continuous bus bar and CT. These are the CTs and post insulators. When each feeder is placed next to each other, these are easily connected to make the continuous bus bar. Bus risers. However, bus is insulated here through the air, and these are just bare copper conductors which are bent according to the design. And the dimension of these bus bars, these conductors are so designed in such a way to carry the maximum design load. Now we will go to the power cable compartment. This is the interface for power cable where switchgear can receive and send the power to the distribution network. These pictures showing the MV terminations. This one is one single MV termination, red, yellow, blue phase. MV terminations are already fixed on the cables, and these are single cable compartments. Receive the cable from transformer incomer, and also cable compartment provide the power interface for outgoing feeders. As per SLD, we can see 5 cables per phase for incomer, and for outgoing 2 cables per phase. But here only single cable is shown, but this switchgear is capable of getting more than 1 cable depending upon your outgoing feeder conditions. Care should be made here by the project team to order the correct MV termination and lugs according to arrangement in the switchgear. Many projects face the difficulty of mismatching, so correct specification should be obtained from the manufacturer of switchgear and transferred to MV termination manufacturer, and project team should make the good coordination here to avoid any mistake at the site. Now something about the auxiliary transformer. Auxiliary transformer is used to step down from 13.8 kV to 400 volts phase to phase and 220 single phase. The rating of the transformer typically is 500 kVA for a normal substation. Its role is very critical, and it supplies the two ACDB panels, supplies for DC system, firefighting system, HVAC, and lighting. So picture at the left is showing the auxiliary transformer, and at right the actual transformer. You can see here this is the 13.8 kV by 0.4 kV, and it is going to ACDB incomer, and this is some details about its rating, percentage impedance, which we had discussed earlier, and this is the circuit breaker which is energizing, and this is the delta and star. The primary is 3-wire system and secondary is 4-wire system which is having neutral, and this is the cable which is from the MV switchgear to the bushing of the transformer. Now we will discuss the last component of SLD, which is a capacitor bank. A capacitor bank in a substation is to improve power factor, which optimizes the overall electrical efficiency, reduce losses, and stabilizes the voltages. Capacitor bank with the reactor has capacitor units, current limiting reactors, porous insulators, lattice steel structure, foundations, CTs, VTs, surge arresters, which are shown in this single line diagram. It is also covered with a sunshade for protection from rain and sun, and also having these fans to avoid any unauthorized access. Capacitor used are here 7 megawatt, shown here the rating, with a 3.8 millihenry with the neutral CT and neutral VT. This is the reactance. 3.8 millihenry is the unit of the reactance because it has a current limiting reactor. Both the neutral CT and neutral VT, neutral CT is shown here and neutral VT is shown here, are there to make the system remain the system in balanced and protected from the faults, while also providing accurate monitoring for the electrical parameters. So you can see here all the details of the capacitor bank, which is designed accordingly, connected through the XLP cables. Their CT classes 5P20 for protection. What is the VT rating? What is the VT secondary? What is the VT primary? What is the VA burden for this CT? What is the class 0.23P? So let us conclude this one here. I would like to give some tips for the project managers here or project team, that while you are designing the MV switchgear, you should get the base design at early stage and share it with the designer to generate the electrical layout. You can do it at early stage as it will open work front for you to start the civil works. This coordination is very important, that the switchgear hall should be designed according to the switchgear itself, especially the openings under the panels, which are actually the cutouts in the floor in the slab. So cutouts in the slab should be done in one time and should be accurate 100%. If you will do the workaround after some costing of the slab, this will compromise the quality and this will is not a professional approach. So make sure that all the openings are matching with the system of the switchgear. For capacitor and auxiliary transformer, you can also get the input from manufacturer and start designing its foundation. Normally the manufacturer has this information readily available because they are producing thousands of the units with the same weight, 8 dimensions. So they can give you the design at the early stage for the civil input. This is all for today. Hope you will get the benefit from this effort, and please share your feedback. It's very important and it will encourage for me to go for the next videos. Next video is going to be very interesting, and this will be for the operational of the pickle feeder and interlocking through a simulation. We have developed a software, a small application which will be interactive and very interesting. We will be try the interlocking schemes and we will see how the substation is energized through one feeder by simulation. Thank you. See you all.